Alright guys, so what we're going to do today in this video is we're going to go over how to do vector operations in the TI-89. So I have this one right here. It's the titanium. I've had it for a long time, and it's the calculator that I use the most. So I have an Inspire, I've got an 83, I've got an 84, but this is the one that I usually use the most because it's very handy to have around. So first of all, let's go over how to actually create a vector. Okay, so remember a vector, you're going to have either two components if you have a 2D system, or you're going to have three components if you have a 3D system. And let's just look at this example here. So if I want to create this vector in the TI-89, what we're going to do is we're going to use these square brackets, just like you see here, and each of the components are going to go in the brackets, and we're going to separate those values with a comma. Okay, so if we come over here, we're going to do second, and then there you go, right here on this button with the little apostrophe. You'll notice it has the bracket, so that'll be that left bracket, and then you're just going to enter the numbers. So we're going to have 1.5, comma, 2.76, comma, 4.89. And then close that bracket by doing second and then the divide button, because notice that bracket's right there, and then you can hit enter. So if you look now, we've got this vector that's created in the TI-89. So we're going to get some results in this form in just a minute. So let's think about what this means. The first value is your X component, second value will be Y, third component is the Z component. Okay, so now that we know how to create a vector and what it looks like, let's start doing our operations. So first let's do addition. Okay, let's do this problem right here. Okay, so I've got this vector and I want to add it to this one. So basically we're going to create two vectors and add them together. So we're going to have 2 plus 2, or not 2 plus 2, 2.2, comma 5.4 minus 8, or negative 8.7, close that bracket. Then we're going to add our second vector. So now open a new bracket, and then we're going to have 4.2, comma, negative 5, comma, negative 3.1. Now we're going to hit enter, and there you go. So the calculator automatically adds the like components and gives you that final result. Okay, so when you add everything, then the result is 6.4i plus 0.4j minus 11.8k. So that would be your resulting vector. All right, now subtracting, you're going to do the same thing. You'll create the two vectors and then subtract. So we'll have 2.2 and then negative, or actually positive 5.4, put a comma, negative 8.7, and then minus a vector that has 4.2, negative 5, negative 3.1. All right, and I'm getting these values from right here. All right, so now there you go. So now the result would be negative 2i plus 10.4j minus 5.6k. And that's what it'll look like. Now you have to have the same number of elements in each vector. If you don't, it's going to give you an error. All right, so make sure you have the same number of components. Okay, so that's how we create a vector, do addition and subtraction. Now let's look at multiplication by a scalar. And this right here is going to be helpful for you guys when y'all are in statics, for example, and you're finding a force vector, right? You're given the magnitude of the force, and then you go through and find the unit vector. You need to multiply all that together. So basically you're multiplying that unit vector by a scalar, which happens to be that force magnitude. So if you know how to do this in vector form, it'll save you quite a bit of time. So all we need to do, let's put our scalar, which is 5, and then multiply it by this vector here. So we're going to have 5 times the bracket, 7.62, put a comma, 15.4, comma, negative 5.34. And then we hit enter. So there you have it. So now you have your new components. It's taken the 5, it's multiplied each of those components by 5, and then it gives you the result. Okay, so when you're doing things like a force vector or something like that, if you create the vector and then just multiply it by the scalar, you only have to do the one calculation. That way you don't have to go through by hand and type in, 5 times 7.62, and then 5 times 15.4, 5 times negative 5.34. All right, so this can really save you some time if you remember to do this, okay, because it just reduces the amount of calculations you have to do. Now those are the basic things that we can do without using any built-in functions. So now I want to show y'all the built-in functions. Okay, so the first one is going to be the magnitude or the norm of a vector. Okay, now to get to this, we're going to use some matrix menus, but that's all right. Vector is just a form of a matrix. So the way we're going to get to this is we're going to hit the second button. Clear that. So we're going to hit second, and then you're going to go to button 5, because button 5 gives you math when you hit second first. Now notice it pops up that little menu there. All right, now what we want to do is we want to go to option 4, which is matrix. All right, now it has this. So to make it easy, let's just hit the up arrow, and then I want you to go up to H, where it says norms. All right, and then go to the right arrow. That first one is what we want. So you can enter. All right, now if you don't remember how to get to that on a test or something, that's fine. You could also go in and use your alpha key and type norm with the parentheses, and it'll work that way. Or you could use the catalog button and search for it in there. Okay, so norm is going to give you a magnitude, so square root of the sum of the squares of your vector. So we're going to have norm parentheses, and then we need to put the vector inside. So we'll have the bracket, and let's just use this example here. So let's find the magnitude of 3i plus 9j plus 7k. So we'll have 3, 9, 7, just like that. Close the bracket, close the parentheses, and then enter. All right, so now you see what we have there. Okay, now you notice I have two different things. I have the square root of 139, and then I have 1.7898. The square root of 139 is what you get if you just hit enter after you type that. If you want the actual, full number there, you hit the little diamond and then enter. Okay? So most of the time you want to hit the diamond and then enter. Okay, because that gives you the actual decimal points and all that. But that's how you'll find the magnitude of a vector. All right, so if you have a velocity vector, you want to find the speed, you could just use that norm function. Or if you have a force vector, you want the magnitude of the force, use the norm function. Okay, that saves you a lot more time compared to using, the square root and then doing x squared plus y squared plus z squared. It's a lot simpler. Okay, so that's magnitude. Now let's look at a few more. So these are going to be under the vector operations menu. Now this is going to include things like unit vector, dot product, cross product. So things you use all the time, especially in courses like statics, dynamics, orbital mechanics, things like that. So let's go ahead and go over how to get to this little menu. So again, we're going to do second, 5. So it takes us to that math menu. And then I want to go and hit option 4. We're going to up arrow and then vector ops. So option L right here. All right, so we got option L, and then if you do the right arrow, you'll notice you've got unit vector, cross product, dot product right there at the top. So those top 3 are the ones you want to focus in on. So let's go ahead and do unit vector first since it's on the top. So this one is going to basically do r bar over the magnitude of r. Okay, it's just going to find your unit vector given just a regular vector. So to do this, let's use this example. 2i plus 5j plus 4k. I want to find the unit vector of that. So we'll have unit v parentheses, open that bracket, and then put in 2 comma 5 comma 4. Close the bracket, close the parentheses. Whoops. All right, and then there you go. So now you've got your 3 components of your unit vector. First one would be your I component. You got the second one, which is your j component, and then you've got your k component right here at the end. Okay, so this is a lot easier than having to go through, find the magnitude, and then divide your vector by that magnitude. All right, it does it all for you, so it saves you a ton of time. All right, now let's do dot product. So again, you get there the same way. Second, 5 button, option 4, hit the up for a little shortcut, and then, whoops, vector ops, right there, option L, right, and then let's go ahead. I've got dot product next, so let's do that one. So dot P. So this one, when you have the dot product, you're taking the dot product of 2 vectors. So you're going to have to use 2 vectors as your input arguments. So let's do the first one. Let's just use this example here. So we're going to have 2 comma 4 comma 8. All right, close the bracket, close the actually not, we don't want to close the parentheses yet. We want to do a comma, and then now let's enter the second vector. All right, so 4 comma negative 5 comma negative 3. Close the bracket, close the parentheses. Now with the dot product, you're going to get a scalar, right? So notice you just get one value here. There's no vector for the result, and that's because it's a dot product. So we get negative 36 for our result. All right, so it's an easy way to do the dot product. Save you a lot of time. Now the biggest help here is going to be that cross product, because how many of us have been in statics trying to do all those cross products on a test, and it takes a lot of time. So if we know how to do it using the calculator, it can really save us some time. So again, same way we got to the dot product function. Now we have cross product. You're going to input your 2 vectors, so let's just use this one here for example. So negative 1 comma 3 comma 8. And then let's do the second vector, so 4 comma negative 7 comma 3. Close the bracket, close the parentheses. Now cross product is going to give you a vector, right? Because it's going through and it's doing the I cross J, J cross K, K cross I, all of those things. It's doing it all for you. You don't have to worry about what sign it is or what the result of the cross product is. You don't have to worry about all that. So this takes care of that right hand rule and everything for you. So if we hit enter, you'll see what you get. You get a vector. All right, so the cross product of these 2 vectors gives you 65i plus 35j minus 5k. All right, so in statics, this first vector would be like r. The second vector here would be like f if you were trying to find a moment, because remember, moments are r cross f. All right, now you do need to make sure the order of the vectors, because otherwise you're going to have your signs backwards. But that's how you use the cross product. That one right there is a huge time saver. I use that one all the time when I'm working out the homework problems for class. So definitely make sure you remember how to get to that one. Okay, so those are the built-in functions there. I want to show y'all one other thing that you might not think of that can actually save you a ton of time, and that is going to be storing vectors. Okay, the way we're going to do that is we're going to store these vectors using a variable or a letter. Okay, and let's kind of walk through that. So let's clear this out. So I'm going to store this vector right here as the letter A. Okay, now the way we're going to do that, let's type out the vector. So put your bracket, 4.3, comma, negative 9.7, comma, 3.2. Okay, so I've got the vector there. Now I want to save this as A so I can use it later on for, a calculation I've got coming up later in my problem. So what I'm going to do, instead of just hitting enter, I'm going to go to this little STO arrow key that stands for store, and I'm going to hit that. Notice it's got this little arrow, and now I'm going to give it a letter. Okay, so you can use the X, Y, Z, or T if you want, or you can use this alpha button and pick one of the letters. So I'm just going to do A, and it gives me that little A. Alright, so then we hit enter. So it shows you your vector. Now if you want to see what's stored in A, just do alpha and then hit that equal button to get A. And notice A is equal to this vector. Okay, now that is a big time saver when you're doing calculations. Okay, because if you have a unit vector you've calculated and you need to use it later on in the problem, you don't want to have to sit there and type all those numbers out again, right? So if you just store it as a variable, then you can use that variable later. So now, let's just say I want to do 10.5 times A. Okay, there it is. It goes ahead and multiplies every component of that vector by that 10.5, gives you the result. And I didn't have to go back through and type the components of A back out, right? It's already in there. So that can save you a ton of time if you get used to using that store button. All right, and one other thing, if you want to use uppercase letters, you can do that. The way you would do that, let's just create another vector here. So let's do that. So there's our vector. I want to store it, and this time I want to use uppercase. So we're going to do alpha, and then this little arrow up here. And then notice it has this little symbol here. And then now hit the equal sign. Notice it switches to capital A. Okay, so if I want to use that later, I would just do alpha up equal. It gives me A, and there it is. Okay, so really helpful built-in functions there on this calculator. That store function is extremely helpful, especially when you're doing a lot of vector calculations. It'll save you a lot of time. Alright guys, hopefully y'all found that one helpful, and next time I'm planning on doing solving equations, so that'll be fun. See y'all then.